What'd you say? It's saying, well, because I took off Monday, it makes it all weird. Okay, we're gonna mute that. Go back here. Okay. So first off, before I get started, you guys can see that, right? Before I get started, are there any questions about anything leading up to this? So 7.5, 7.5, 7.6. Any questions on either of those sections from yesterday?
I was having problems with the 7.5 homework with the cube root.
Okay. Oh, did I give you one with the cube root?
Yes.
Okay, hold on. Give me a second. Which page is that, Amanda?
It's 548.
548. I didn't think I gave you one with a cube. What number?
Number 9.
Yeah, you can get rid of that one. I meant to only give you ones with square roots. I apologize.
Okay.
Yeah, that's why I was like dancing around. Like, how I didn't just do like 1 through 43 odd or something. Like, I didn't mean to give you one with the cube root because we're not going to see it in college algebra at all. So, not worried about it.
That's the only problems I had.
Oh, perfect. Yeah, those would be problems if I hadn't gone over them. I agree completely. They're a little different. You guys have any issues? Any other questions? Comments, concerns? Okay, let's get going. So today we're going to hit the harder questions from 7.6. 7.7 is not going to take long. So we still might get a nice review tomorrow over these 3 sections. So 7.6, remember, was rationalizing denominator. Oh, no, I'm sorry. That was 7.5 that Amanda just asked me about. 7.6 was on solving. And I only gave you, I believe, the very first part was like 1 through 9 odd. I could have given you 1 through 13, that's fine. But I want to look at some now that are a little more complex. They're going to take a little more time. And we're going to have to utilize past ways of solving, mainly solving by factoring. You'll see it pop up in this section. But remember, if you go back to solving radicals, we isolate the radical, we raise both sides to whatever the root is, and we solve it out, and then we check it. Remember, we have to check it. So I'm going to follow those directions. I'm going to just steal one. This is number 16 out of the book. So 16 says the square root of 2x minus 3, now that's under the radical, equals 3 minus x, okay? So just kind of going through the steps from yesterday. Step 1 is we had to isolate the radical. Well, we have it isolated here, right? This square root is by itself on the left-hand side. So we don't have to worry about isolating. All we have to do at this point is take the square of both sides. So we have to square both sides. And what's nice on the left when we do that, of course, the square root and the square go away. We are left with 2x minus 3. On the right, though, we have to FOIL this out. Remember, I know I've harped on this a few times because it's one of my main pet peeves in algebra, but we can't distribute that square to the 3 and the x because there's a minus sign there, right? If it was 3x, we could, but because it's 2 separate terms, we have to FOIL this out. So I'm going to write it out like that and then think of foiling it. So first we'd have 9. Outside we'd have minus 3x. Inside we'd have minus 3x. And then lastly we'd have a plus x squared. Okay? Now I'm going to pause it right here because this tells me, because we have an x squared, this tells me that this is going to be a different kind of solving. It's just not a linear solving where, like we only have x's and we have to get them all by themselves and, x's on one side, numbers on the other, right? We can't do that because we have an x squared. And because we have an x squared, we have to, actually for this section, I'm going to tell you, you're always going to solve by factoring. It's the only solving we've gone over. But in chapter 8, we're about to go over how to solve these a lot of different ways. That's next week. But from this point forward, because I've got the x squared, I know this is going to be solving by factoring. And remember, to solve by factoring, we had to get one side equal to 0. And I like a positive x squared. It actually helps us out a lot. So I'm going to move all this over to the right because we need one side equal to 0. So if you've slept a little bit since we've solved by factoring, I'll kind of give you a little review. So I'm moving this stuff to the right. So subtract the 2x over here. Now we've got 3x terms, right? And then add the 3. So we wind up with 0 on the left, 12. Now we've got minus 3x minus 3x minus 2x. So that's what? Minus 8x. Plus x squared. Okay. Now look, I'm going to write this in descending order because we can do the quick factoring. Remember, if x squared was by itself, we could do the quick factoring. So I'm going to write this a little differently. I'm going to say 0 equals x squared minus 8x plus 12. We can change the order, right? It's all addition or subtraction. And then, okay, so solving by factoring. Once we had 0 on one side, we had to factor the non-zero side. And this, because x squared has a coefficient of 1, we can see, well, what two numbers multiply to give me 12, add to give me negative 8? Oh, that's going to be negative 6 and negative 2, right? Multiplies to give me positive 12, adds to give me negative 8. Then I put both of those equal to 0. That was the 0 factor property. And then just solve them out. So x equals 6, right? Add the 6 over, add the 2 over, and we get x equals 2. Woo. Okay. Now, I told you. I said, hey, we're about to do the harder ones in this section, right? I warned you. And it's because, look, first, we're squaring both sides, multiplying it out. And then what you're going to see in these harder ones, after you do that, it's going to turn into a quadratic. Okay. It's going to turn into solving by factoring. And then you're going to factor it completely. Okay. So it's just, in a way, it's one more step, but it's a doozy of a step because it's solving quadratics. Okay. Or solving by factoring like we did earlier. Now, the last step, remember, is we have to check these. I'm going to tell you, like 9 out of 10 times, one of these is going to work and the other one isn't. And it has to do with squaring. Squaring and radicals get real goofy with positive and negative stuff. So one of these probably works and one of them doesn't. It just tends to happen in this section. So first I'm going to check 6. Now look, I've got to check one at a time. And I have to go back to the very beginning to do this, okay? Got to go back to the very beginning to do this. So I'm going to put in x equals 6 here. And I'd have the square root of 2 times 6 minus 3. Now I want to know, is that equal to 3 minus 6? So remember, underneath the radical, you got to multiply first. 2 times 6 is 12, minus 3 is 9. And then on the right, we get 3 minus 6. Well, that's negative 3. This is not true, right? Look, the square root of 9 is positive 3. It does not equal negative 3. And just doing a quick check, make sure I didn't miss a sign or anything goofy. Yeah, 3 minus 6, yeah, that's negative 3. So turns out I have to throw out the 6. Now, I might also have to throw out the 2. So it's not that you can just automatically say 2's the solution. So let's see if 2 works. X equals 2. So we get the square root of 2 times 2 minus 3. And I want to know, is that equal to 3 minus 2? Well, 2 times 2 is 4. Minus 3 is 1. So we get the square root of 1 on the left. And we get 3 minus 2 on the right. Yeah, that's 1. This works out, right? The square root of 1 does equal 1. So therefore, that is our only solution, okay? A lot of work. Oh, excuse me. A lot of work for just a single solution. I'm going to tell you on the test, because it's multiple choice, what's going to happen is I bet one of these answers is going to be like 6 and 2. And you're going to get to this point and go, oh, check, done. But you're wrong. You did all that work for nothing, okay? You've got to make sure to check your answers on this, okay? Questions? Okay. Let's do another. Actually, I'm going to leave this one here if you want to look at it. And I'm going to add another one, though, and I want you to try. It's number, not too far after that. Let's see. Yeah, let's do like number 18. So 2x plus the square root of x plus 1 equals 8. So now on this one, you're going to have to move the 2x over, right, to get the radical by itself. So that's the only real difference to begin with. So try that one. Try that one. Okay, keep working. I'm going to start this, but I want you to keep working because these these just take time. There's not really a quick way to do them. He's green now. Money. Okay. So I'm going to move the 2x over. So I get the square root of x plus 1 equals, now you can either write negative 2x plus 8 or 8 minus 2x, doesn't matter. Excuse me. Once we square it, it's all going to come out in the wash. So I'm going to write this as 8 minus 2x. But you'll see, if you square it, you'll get the same thing. At this point, I'm going to square both sides. So on the left, I wind up with x plus 1, right? Because that's nice, it goes away. On the right, I need to think of this as x minus 2x. I'm sorry, 8 minus 2x times 8 minus 2x. So I wind up with 64 minus 16x minus 16x, and then plus 4x squared, right? Now I'm going to move this stuff to the right. So I'm going to subtract the x and subtract the 1. And I get 0 equals 63. Is that minus 33x plus 4x squared? Jesus. This one's crazy. Oh, Lord. How does the answer look so normal? Okay. So we've got a, did you guys get this? Okay. I'm sure I didn't write it down or something. But I'll move the 2x over. Okay, yeah. Squared 8 times 8, 64. 16 minus 16 minus 16. And then plus 4x squared. Yeah. Okay. So now we've got to factor this. So I'm going to get my phone out because those are kind of big numbers. I do not have enough fingers and toes. So remember, we can't do the easy way here because there's a 4. Now I'm going to write it in order. So 4x squared minus 33x plus 63. So now 63 times 4. Remember, this is the AC method. 63 times 4 is 252. I guess I'll write that somewhere up here. Ooh. And I got to find two numbers that multiply to get 252 that add to get negative 33. So 252 is divisible by 2. That's not going to work. It's divisible by 4. We know that's 63. So what about 6? 252 divided by 6. 42. We're getting closer. 42 and 6. Probably 8 maybe. 252 divided by 8. Nope. It's not divisible by 8. 252 divided by 12. There it is. 12 times 21. Okay. I mean, all I did was just go through and just see, 252 is divisible by 6. It wasn't divisible by 8. It wasn't, of course, it's not 10. So then I did 12. Well, 12 times 21 adds up to 33. It'll add up to negative 33 once you make both negative, right? Both negative add up to negative 33, multiplied to give me a positive 252. Woo, that was rough. Okay, so now we're going to do the AC method on this. So 4x squared, split apart the 33, negative 33. Okay, so 0 equals 4x squared minus 12x, that's one group, plus negative 21x plus 63. Okay, out of this first group, I can factor a 4x out. I'm left with x minus 3. The second group, the 63 is divisible by 21. It's 63 divided by 21 is just 3. So we need, though, that for this term to be positive, look, and then that second term to be negative. So I'm going to factor out the negative 21. And I wind up with x minus 3. These match. So we get x minus 3 times 4x minus 21. That's going to be fun to check. Okay. And then so we wind up set each one of these equal to 0. It's kind of right over here. So if x minus 3 equals 0, that's just x equals 3. 4x minus 21, though, equal to 0. Add the 21, divide the 4, and you wind up with x equals 21 fourths. So that's our two options. I need a whole new piece of paper to check these. Okay. So now, hold on. I'm going to write this down. So I think one of the solutions is x equals 3, and the other one's 21 fourths. Okay. So I'm going to cover this up real fast. So if you want to write this down, I'll give you a minute. Because I'm going to just check it, just to show you how to check it. Okay. So let's go back up here and I'm going to check both of these, right? Let's do x equals 3 first. So we get 2 times 3 plus the square root of 3 plus 1. And I want to know, is that equal to 8, right? 2 times 3 is 6. Plus, now this is 4, the square root of 4 is just 2. Yeah, this one works out. This is what I was talking about. Like, this is a normal solution, right? Something crazy. Okay, let's check out 21 fourths. So we get 2 times 21 fourths plus the square root of 21 fourths plus 1. And I want to know, is that equal to 8? Now look, this would be the time to take your calculator out and add those two together because it can do it and it'll pop it out. I'm going to do it real fast. Actually, let's multiply these first. 2 times 21 divided by 4. Well, the 2's, this cancels. It leaves you with a 2 in the denominator. So you wind up with 21 halves. Okay. Plus the square root. Now look, 1 is just 4 over 4. You've got a common denominator. You add the tops. You wind up with 25 fourths. Okay, your calculator can do that quicker than me. And now we can remember this is the whole square root, right? So we take the square root of the top and bottom, and both of these have square roots. So that's kind of nice. Square root of 25 is 5. Square root of 4 is 2. And then 21 plus 5 is 26. Well, 26 divided by 2 is 13, right? 13 does not equal 8. So not that we did all that in vain to find out it was wrong. We had to know that this wasn't a solution, okay? So we had to do all that to show that it wasn't a solution. This one was a doozy, guys. Holy cow. So you might want to go back and look at this one if you've got more time, in the video, right? You might want to go back and kind of watch this. Just maybe pause it even, because it's a lot going on. So I mean, but the first stuff is just like the easier one. We got one side, the one side we isolated the radical, squared both sides, we had to FOIL out the right, but then it turns into a quadratic because we have an x squared, 0 on one side, everything else on the other. And then we had to factor this. That's really what took up the most of the time, right? We had to factor this down into x minus 3, 4x minus 21, get those two solutions, but then eventually we had to get rid of this solution, right? Because it didn't work out when we checked it, okay? It did not work out when we checked it. Yeah, that's a lot. Holy cow. That turned into a lot. Okay, let's do another type. What if we had two radicals? And this will happen every now and then when we're solving in this section anyway. But what if we have two radicals? So let's look at an example where we've got two radicals now. Let's say like 20. Oh my Lord. Let's do 22. Yeah, let's do 22. So we've got the square root of 2x minus 4 minus the square root of 3x plus 4 equals -2. Now I'm going to tell you, just buckle up because it's going to take a little bit, okay? I'll work this one with you just to kind of show you the step-by-step of it, but it's going to take a little time. We're going to follow the directions, but we kind of have to follow them twice. We're going to isolate one of the radicals and then square both sides and then isolate it again. You'll see what I'm talking about. But remember, the first step's isolating the radical. We've got a minus sign here, and I don't like negative radicals. So what I'm going to do is actually isolate this radical first. I'm going to move this entire radical to the other side. Okay? So we wind up with the square root of 2x minus 4 equals the square root of 3x plus 4 minus 2. Now notice that minus 2 is outside of the radical. Okay? So we've isolated this radical. We follow the same directions we've been doing so far. We're going to square both sides. And you guessed it. We're going to have to FOIL this out. This is going to be kind of crazy. But look, I'm going to have to write this as the square root of 3x plus 4 minus 2 and the square root of 3x plus 4 minus 2. Okay? On the left, it's kind of nice. This is just 2x minus 4. We did really what was intended. We got rid of the radical for this one. Okay? Whew. Now we're going to have to FOIL this out. I need you to think a little bit. We've done a lot on radicals the last 2 weeks. If I multiply these first two together, really what I have is the square root of 3x plus 4 squared, right? It's going to get rid of the radical, so that's cool. And then let's do the outside. Now we can't multiply these, but remember, it's a coefficient and it's a radical, so we just put it in front of it. So 3x, negative 2, 3x plus 4, right? Inside, same exact thing. Same exact thing on the inside. Lastly, though, we got minus 2 times minus 2. That's a positive 4. Okay, so that would be FOILing out these two binomials, which are, it's kind of crazy because it's a binomial radical and not just a number, right? Not just a single term. Let's see what we have once we clean this up. So we got 2x minus 4 equals, look, this square root and square cancel. So we're left with 3x plus 4. Now look, hey, these two can add together. They're like radicals. It's the same root and same radicand. So we wind up with minus 4 square root of 3x plus 4. And then the plus 4 is hanging out on the outside. Okay. Let's kind of catch up a little bit. It's weird. This one's a little crazy. Okay. But what's nice, if you look at this equation, we only have one radical now. Okay. So now the goal is going to be to get this guy isolated. Let's clean it up a little more. I'm going to add the 4 and 4 together. So we get 2x minus 4 equals 3x, 4 plus 4 is 8, minus 4 square root of 3x plus 4. Okay. Now we're going to have to isolate this guy. Okay. Now to do that, remember, we're going to get rid of the addition and subtraction first and then divide everything by negative 4. That's what we're going to have to do. So the first thing I'm going to do is subtract the 3x and subtract the 8 on both sides. Hold on. What number was this? 20? Nope. 22. Yep. Okay. So on the left, we get a minus x, right? 2x minus 3x minus 12 equals negative 4 square root of 3x plus 4. You know what? I'm going to be a little lazy here. And instead, look, at this point, technically, how I've told you to work these, you're supposed to divide this negative 4 on both sides, but negative 4 doesn't divide by x. So what I'm going to do at this point is actually square both sides. It's kind of neat. Follow me here, okay? I'm going to square both sides. On the left, I have to FOIL this out, okay? Minus x minus 12 times minus x minus 12. Not a big deal. We'll FOIL that out here in a second. But here's what's neat. On the square here, think of this as these two things are being multiplied, right? I'm going to square the negative 4, and I'm also going to square the radical. Because they're being multiplied, okay? Because they're being multiplied, I can do that. Okay, let's FOIL out this left-hand side. So we get negative x times negative x, that's a positive x squared. And then negative x times negative 12, that's a positive 12x. Same thing for the middle. And then lastly, negative 12 times negative 12, that's a positive 144. Okay. Give me some more paper going on right here. Extending the page. And on the right, negative 4 squared, that's a positive 16. Times, now this square and square root go away. 3x plus 4, that just goes away. Whew. I'm going to add these two on the left, so I get x squared plus 24x plus 144 equals, now I've got to distribute the 16. 16 times 3x, is that 48, I believe? So that's going to be 48x. 16 times 4, that's, I think that's 64. Okay. And now look, I've got a quadratic going on. After all that work, we are finally down into a quadratic, right? We've got the x squared on the left. We're going to move these over and we're going to just do the quadratic, I'm sorry, solving quadratics by factoring, right? So I'm going to subtract 48x, subtract 64, and I wind up with x squared minus 24x. What would that be? Plus 80? Yeah. Phew, man. We can do the easier or the quicker factoring because x squared is by itself. I'm going to bring up 80. I'm going to write it up here. Okay, so we'll bring up 80. Think of things. I know, 8 and 10. So is that it? Yeah, 20 and 4, right? Now they both have to be negative because when you multiply them, you get the positive 80, but then when you add them, you get the negative 24. So minus 4 minus 20. Set each one of those equal to 0. And we wind up with x equals 4 and x equals 20. Okay. Wow. That was intense. Okay. We got to check them. They might both be wrong. Let's go back to the very beginning. Actually, I'm going to rewrite the original up here, and then we'll just check them on this page. So the original equation was the square root of 2x minus 4 minus the square root of 3x plus 4 equals negative 2. That was the original equation. So I'm going to check one at a time. So let's check x equals 4 first. So x equals 4 would be the square root of 2 times 4 minus 4 minus the square root of 3 times 4 plus 4. And I want to know, is that equal to negative 2? Well, 2 times 4 is 8, minus 4, so that's the square root of 4. Minus 4 times 3 is 12, plus 4, that's the square root of 16. Yeah, it's going to work out. This is going to be 2 minus 4, which equals negative 2. So that tells me the 4 works, okay? The 4 works. So let's check out 20. So same thing. I'm just going to plug in the 20 now. 2 times 20 minus 4 minus the square root of 3 times 20 plus 4. And I want to know, is that equal to negative 2, right? So 40 minus, this is 2 times 20, it's 40. Minus 4, that's the square root of 36. 3 times 20, it's 60. Plus 4, that's 64. So this would be 6 minus 8. Hey, they both check out. They're both solutions. That's kind of neat. That does not happen that often, okay? It does not happen that often. Okay. Questions other than what? This is a lot of work. It just is. It's just a lot of work. And you'll see some of these are actually easier than others. I'm going to pick a few of them, and they're going to look hard for you on the homework, but they're going to turn out to not be that hard. So for homework for this section, just right here, to complete the homework, I should say, I'm going to make sure I don't choose one that I don't want here. Do 15, through 27. These are all going to be odd. 31. The stuff at the end is kind of a mixed bag. So you're going to see some stuff that's kind of easier and then not so easy. And it's kind of nice getting that practice in. Yeah. I'll tell you, like 45 is it's two radicals, but it's way easier to just square both sides and solve it. 47 and 49. Yeah. So to finish up 7.6, and this is on page 560 and 561. It's 15 through 27, 31, 37, 39, 45, 47, 49. Now, these are all odd. Just do the odds, okay? You should be A-okay. Okay, great. So now we're going to go over 7.6, and I'm going to tell you 7.6 is not going to take us long. We're going to go over the what you need to know for college algebra lecture in 7.7. 7.7, which is over complex numbers. Complex numbers. And it's pretty basic what you need to know. And before we get to really what the complex number is, you have to talk about the imaginary unit. Remember, harken back, okay, when we first, I think it was in 7.1. So like last Monday or last Tuesday, we talked about, hey, you couldn't simplify, the square root of negative 25, right? We just said it was non-real. Well, now we're going to deal with it, okay? We're not going to say it's non-real from now on. We're going to use this imaginary unit. And what this imaginary unit is actually is the square root of negative 1, okay? The square root of negative 1 we're going to write as I. For some reason, it's italicized always. I don't know why. So I try to make it look a little different than just a regular I. But it is an italicized I, and it means the square root of negative 1. And we can use it now when we simplify these. And I'm going to show you kind of long ways how it works before we just get to more simplifying examples. Long ways, what happens is you can write this negative 25 as negative 1 times 25, right? And then what we can do is we can take the square root of both of these, okay? So the square root of negative 1 just turns out to be I. We defined it right here, right? And the square root of 25 is just 5. Now we write the I second because it's kind of considered, like a variable, but it's not a variable. So it's 5I, okay? 5I. So it is non-real. We weren't lying, okay? I didn't lie to you. It was a non-real answer. It's just that from now on, we're going to simplify it with the imaginary unit, okay? The imaginary unit's going to be 5I. Not a big deal. Questions? No. Okay, so let's look at a few of these just to get comfortable with pulling out the I. So if we had something like the square root of negative 7, now look, 7 doesn't have a square root, completely true. But we still have to take out the I. So I'm going to take the square root of negative 1. Now when I do this, we put the I like we would an X, like we would put it in front of the radical. So it'll be I square root of 7. Okay, I square root of 7. Now I know what you're thinking. No, I don't, but up here you might be thinking, hey, you told us to write the I to the right, but down here it's to the left. And it has everything to do with like handwriting. This I is not under the radical because we took the square root. And if I wrote it like this, which there's nothing wrong in doing that, but you can kind of see how it kind of looks like the I is under the radical, and it's because of handwriting. So that's why we don't write it like that. We write it out front, okay? That's why we do that. So let's say we had something like 4 square root of negative 20. Okay. Okay, so this would be, 4 square root of -1 times 20. I'm going to break down the 20 over here because it's a radical. I've got to simplify it, right? 10 times 2, 5 times 2. Oh, yeah. We can take a 2 out of that 20. So we can take a 2 out of the radical. It's going to leave us with a 5. But we can also take the I out, or we have to take the I out, okay? So I'm going to kind of write what comes out and what stays in and not just do it all in one step. So what comes out, we've got a 4 that comes out, or it's already outside, I should say. We've got a 2 that needs to come out. We've got an I that's got to come out. And what's left over is just this 5. So we wind up with 8I square root of 5, okay? 8I square root of 5. Okay? Questions? I'm trying to think of anything that might be kind of goofier. Well, okay, I mean, if there's already a minus sign, if we had like, let's say minus square root of, you try this one. Now that minus is just hanging out on the outside. So minus square root of -75. Simplify that one, see if we can do that. Okay, I had to break down 75. I know it's 3/4, right? And then 5 times 5. Okay, we can take a 5 out, right? So now look, I'm going to kind of do this in one step. There's already a negative here. That's not a big deal. So I'm going to take the 5 out, make it -5 because it's negative on the outside. It's a negative under the radical, so that just means it's an I. And we're left with 3. Okay, so you can kind of do this quicker. You don't have to write out as much stuff. That's kind of what I'm wanting to show you. You don't have to write out as much if you kind of do it like this. Okay. Questions? Not too bad. Okay, let me go over a little bit about the complex number now. So that's the imaginary number. And the complex number, though, turns out to be every number that you can think of it as either humans have discovered or every number that humans have stumbled upon in a way. I guess that's the same as discovered or made up, I guess. But they look like this, the complex number. A plus BI, okay? So now if you've never seen imaginaries before, the I part's brand new. But this is every single number you've ever dealt with your entire life, okay? We have not found any new way of writing numbers or forms of writing numbers. The imaginary really kind of came out of the square root of negatives. So we had to develop this. I say we, I didn't do it, but somebody before me did it. But part of the complex number and why it's complex is there's 2 parts. It has a real part and an imaginary part. Okay. So if you like Venn diagram circles, we drew like a big circle. Here's every single number. Every single number we've ever learned about ever, or we've ever found, like that's ever happened. Okay. Now, inside that set of complex numbers are real numbers. So like a complex number would be something like, oh, like what we just found out, like 5i. Okay. 5i would be a complex. It's not real, right? It's imaginary. It's got the I on it. Another complex number would be like -2 plus 6i. Okay. That would be a complex number. It has a real component, right? -2 would be considered the real component. The 6 would be the imaginary component, but because it has an imaginary component, it's complex. But real numbers would be stuff like, 1/2. Okay. Now, 1/2 you can write in complex form. And I didn't really tell you about that earlier, but you can write like 5i or 1/2 in complex form. You would just need a 0 for the other part. So like 5i, you would write it as 0 plus 5i, right? It just means that there's no real part to this. And the real part, or the 1/2, you would write as 1/2 plus 0i. It's just goofy. We don't write it like that. We wouldn't do that, but that would be how you write it in complex form. Okay, so every single number you've learned so far, you can write in complex form. Now, God, anything's real up to if it doesn't have an I in it, right? Like the square root of 2 is real. Okay, all of that. Now, inside of this real bubble, there's other bubbles you might have remember learning about, like rational numbers and whole numbers and integers and all that stuff, right? That's in the real bubble, okay? But understand the complex, those are all considered complex as well, okay? We don't know anything, like everything outside of this egg white here, right? That we don't know yet. We haven't discovered it, or we haven't really come up with a way of defining it. So kind of neat stuff. And that's all I care about you learning with imaginaries, because that's all we're going to use in college algebra. We won't reuse the complex number part. I just feel like I'm not doing you a good service if I don't explain where the heck these things are coming from. Okay. So for homework in this section, it's not that long. I just want you to do 1 through 15. Actually, 1 through 16. I want you to do all of them because there's not that much. And that way you've seen all the simplification. We have to know how to simplify these things for chapter 8. When we start solving, chapter 8, we're going to go on to solving quadratics. And to solve quadratics, you have to know how to simplify radicals. Actually, it turns out to be one of the hard parts. Simplifying radicals and simplifying fractions turn out to be the hard parts in solving quadratic equations. This is section 7.7. Okay. Do you guys have any questions? Okay, hold on. I'm trying to think. There was oh yeah, I know what I wanted to show you. Let me put this video on me for a second. Oh, shit. So let's say, I got a lot of questions about seeing old tests, and I put something in Blackboard, and I want you to check it for me to see if you can see your old tests now. And I wanted to show you how to do that. The issue is I've got an instructor view, so I haven't taken these tests, so I don't know, or I haven't taken them in Blackboard. I took them before to make sure they were right, right, but not in Blackboard. But let me show you. Let me make sure I don't have anything crazy. Let's do screen share real fast. We'll share this screen. And then let me go to Blackboard. And when you go into Blackboard, you're going to see, let's scroll down to find your class. I put a gradebook button in here now. And this is what another instructor told me to do. I mean, I thought that for you to view your test, you'd have to like just go back and click on the test. But it looks like when you click in Blackboard, like it'll be in there. And then you can see what you missed or what you got right. Check that for me. Let me know if that works. And it looks like I have this one graded. Yeah, okay, good. So like I probably just clicked on this just to make sure it would work. And I made a 0. And when I click on the 0, yes, perfect. Okay. It shows me, hey, look, you missed everything. Okay, I probably just tried it one time. So that's how you go in and check it. I didn't realize it would be such a tedious issue in Blackboard. And I apologize for not getting that gradebook button in there sooner. I was really trying all these weird things in the background, and it was something very straightforward. Okay. So I know a lot of you guys have asked me about that. So I'll put that in there. Check it out. If you can't see something now, the only one I know you won't be able to see is test 1, because remember I had issues with test 1. And I'm going to try to find a practice test that has the answers in it so you can review test 1. And that way it won't be the same that you took, but it'll be very similar to what you took. Okay, great. Any questions? Let me stop this. Any questions out there? Amanda, Jarrett, you guys have any questions? We're good to go?
Yeah, I'm good.
Okay, good. Great. I will see you guys tomorrow. So tomorrow we're just going to review. We're going to go over 7, 5, 6, and 7. So 7.5, 7.6, and 7.7. And then I'll open up that test like we've been doing the whole time. Now, listen, guys, this is the last test, right? The last regular test. And then the final will be next week. So great. I will see you all tomorrow. Let me end this thing. Hold on. And